So we will get into the ENG and VNG. ENG is the electronystagmography, okay, and the VNG is your video nystagmography. Okay, let's leave this electro and video. What is nystagmography? We know what is nystagmus, right? Nystagmus is a rapid eye movement. When we are trying to make it like a graph, we are going to call it as graphy. Okay, so nystagmography is a graph of nystagmus, a pictorial representation of nystagmus. Okay, based on what, using what we are going to do this graph. If you're going to use the electrodes, then it is called as electronystagmography. And if you're going to use capture videos, then it becomes your video nystagmography. Okay, so how does the electronystagmography works? When we do an ABR, usually we keep our negative, we keep our positive electrodes based on what? When there is a firing, your cochlea will have more of potential when compared to the other side, which means you have negative close to cochlea and you have positive close to forehead. Okay, compared to the positive, the cochlea has more of potential. That's why it is recording as a positive signal, the recording. Okay, what happens if you change it? If you change the positive to negative and negative to positive, okay, when you compare now, compared to the negative, the electrode, compared to the electrode in the forehead, what you have kept in the near the cochlea will record more potential than the other. Okay, so when there is a potential difference between the two electrodes, it will be recorded as a response. Okay, in this example, your eye also has a positive and negative orientation like your dipole. Okay, what happens? The front of the eye is considered having a positive charge and the back of the eye is considered to have negative charge. Okay, now imagine we have kept an electrode on both sides of the ear. Okay, one towards the lateral side and one's in the medial side close to your nose. Okay, so what happens when the eye is turning towards your right side, which is it is trying to look on the midline close to nose, the electrode placed near the nose will record a positive response. Okay, because it is recording more positive when compared to the other side, lateral one. You need two electrodes to record anything. We definitely need two electrodes to check the difference, potential difference. With one we cannot say. So if the eye is looking towards the right side, then we are going to say that the patient is uh, the electrode on the right side is going to pick up positive response. If it is looking on the left side, then we are going to have negative. Why? Because one will be your inverting electrode, another one will be your non-inverting electrode. Okay, so based on one electrode, the non-inverting electrode, the positive electrode, then we will see what is the change. Is it more or less? Okay, just a minute, I will. Okay, imagine if a person's electrode is kept here and here. Okay, two areas. In this example, only horizontal. We also keep electrodes on the positive side also, I mean vertical side also. Now that we are keeping an electrode here and here. Okay, now in this example it's on the left side. Okay, I'm keeping this right and this is left. Okay, if I'm looking straight, okay, as in the example A, I'm looking straight, so this has positive and back of my eye has negative charge. Okay, now both the electrodes are recording equal. It doesn't deflect. It is a flat line. Okay. In case if I'm looking like this, okay, which means I'm looking at a direction close to the electrode here, this positive charge is closer to this electrode. The back of my eye had negative charge which is close to this electrode. Okay, so compared to this electrode had more positive charge, so it is going to have a peak. It will have a peak. Okay, if I'm looking this way, okay, so this way means this is recording positive, this is recording negative now. Okay, but we will take only one electrode as reference. That's why we say reference electrode. Okay, we have reference electrode and they have active electrode. So we will record based on the orientation with active electrode. From the active electrode, did the electrical impulse increase or decrease? That was we will record. This is my active electrode. Okay, this is my active electrode and I have turned my eye towards this. Compared to reference electrode, the active electrode has positive charge, so I will have a positive deflection. Then I am turning towards this side. Okay, compared to the active electrode, I mean compared to the negative electrode, the active electrode is having less charge. Why? The positive is towards the negative, positive is towards the this electrode, and the negative side of my eye is towards the active electrode. So compared to this electrode has less charge, so I will have a ground deflection. Is it? So this is how we are going to place the electrodes if you're going to test a patient. We will keep two horizontal electrodes. Okay, one on the one side, another on this side. Okay, and then we will keep one on the forehead as a ground, and then we will have two vertical electrodes. Okay, so this will tell me which side I am actually looking. Okay, this is only for ENG, electronystagmography, not VNG. Okay, in ENG we use electrodes, in VNG we will use videos. Okay, fine. This is what happens. Look at the A. Okay, the A is actually looking straight. There is no change in the movement. Okay, so what did it record? We had two channels here. One is a horizontal, a vertical channel. Why? We need to know if the eye is moving in the horizontal direction or in the vertical direction. Okay, so we are keeping two channels. One channel is to check if there is a movement in the horizontal plane, and the other channel is to check if the eye is moving in the vertical plane, which is up and down. So if either the eye turns right and left, it will be recorded in the horizontal channel, and if it is moving up and down, this movement will be recorded in the vertical channel. Okay, so you will have a ground also. Why do we have ground? To get a value for these electrodes. Okay, so then what happens if the eye is moving in one direction? Okay, that's what we want to know. Look at this. The horizontal, just a minute. Okay, so look at this. This eye is looking towards this direction, which means this electrode records a positive signal and this will record a negative signal. Clear? When the eye is looking in one direction, one electrode which is closer to the eyeball, meaning the retina, will record the positive charge, and this will have negative charge now. Okay, so you will see negative and positive. So what happens here? Baseline and then it increased, right? Okay. So what happened here? There was a baseline, and since there was a movement, it increased and then it continues. The eye is still looking here. Okay. But was there any movement in the horizontal vertical direction? No. So the vertical recorded no movement at all. Okay. Is it clear how the ENG works?